Supposedly, we have currently reached a crucial point in mankind's knowledge of the physical universe. After millennia of stumbling awkwardly to explain phenomena, mankind has reduced physical reality to a finite number of isolated building blocks, the components of subatomic particles, whose interactions are governed by a finite number of physical forces and laws. Though the exact character of these components and these laws is unclear, what is clear is that ultimately, from the behavior of these components in the small, we can derive the entirety of the phenomena of the physical universe. The laws of physics, motion, fluid flow, physical chemistry, living phenomena too, are quickly being reduced to complex interactions among these tiny, fundamental components. Even the seeming complexity and variety of human activity is in the process of being analyzed into its organic components. But does this view of science even remotely resemble the mode of creative thought by which humanity has been able to develop consistently over millennia? And if not, from where did this cold view of reality arrive? Let us begin by answering the first of these questions and take a look back to the dawn of modern physical science. The astronomy of the ancients was transformed into the field of astrophysics by the work of Johannes Kepler at the end of the 16th century and the beginning of the 17th century. Whereas astronomers before him had worked meticulously to chart the positions of the heavenly bodies against the nighttime sky, Kepler recognized that it was possible to determine the nature of the physical world, of which the motions seen on that nighttime sky were merely a projection. Because of this, he avoided merely projecting the properties of the visible world onto that invisible world, which lay beyond the celestial sphere. He avoided any attempt to reduce those celestial motions to any sort of mere mechanics. Rather, he looked towards the metaphorical presentation of the idea which must necessarily govern the motions observed.
We perceive how God, like one of our own architects, approached the task of construction of the universe with order and pattern, and laid out the individual parts accordingly, as if it were not art which imitated nature, but God himself who had attended to the mode of building of man who was to be.
For Kepler, because the mind of the creator of the universe was mirrored in the mind of man, any investigation of the physical universe had also to be an investigation of the mental processes which accompanied human creativity. In particular, in his Harmonies of the World, this took the form of a study of the musical relations which the mind of man uniquely recognized. And because man's mind responds to such relations, Kepler recognized the mind of the creator must also have expressed these relations in that creation itself of which man is a part. Thus, the invisible relations among the harmonies became the principle which governed the visual manifestation of the created universe. This methodological approach gave rise to a completely ordered solar system, which included the discovery that planets moved in almost imperceptible ellipses, whose eccentricities were defined by the musical intervals formed between the planets at their apihelia and perihelia, orbiting the Sun at distances spaced according to the Platonic solids, such that the cube of the ratio of any two planets' average distance was equal to the square of the ratio of their periods, and that the area traversed by the planet in its orbit was proportional to the time required to traverse it. Thus, at the inception of astrophysics as a science, there was no difference between the cognitive capability of the human mind and so-called physical science. This approach disturbed a number of people. One of these people was Pierre-Simon de Laplace, writing later in the 18th century from Napoleon's France.
In Kepler's time, the world had just begun to get a glimpse of the proper method of proceeding in the search of truth, at which genius only arrived by instinct, frequently connecting errors with its discoveries. Instead of passing slowly by a succession of inductions, from insulated phenomena to others more extended, and from these to the general laws of nature, it was more easy and more agreeable to subject all the phenomena to the relations of convenience and harmony, which the imagination could create and modify at pleasure. Thus, Kepler explained the disposition of the solar system by the laws of musical harmony. We behold him, even in his latest works, amusing himself with these chimerical speculations, even so far as to regard them as the life and soul of astronomy. He has deduced from them the eccentricity of the terrestrial orbit, the density of the sun, its parallax, and other results, the inaccuracy of which, now discovered, is a proof of the errors to which we expose ourselves in deviating from the route traced by observation.
Instead of Kepler's approach, Laplace chose to promote the methods attributed to Isaac Newton, who famously declared that he did not make any hypotheses of the sort which Kepler did.
I have not as yet been able to discover the reason for these properties of gravity from phenomena, and I do not feign hypotheses. For whatever is not deduced from the phenomena must be called a hypothesis. And hypotheses, whether metaphysical or physical, or based on occult qualities or mechanical, have no place in experimental philosophy. In this philosophy, particular propositions are inferred from the phenomena, and afterwards rendered general by induction.
Not bad sounding, but what did Newton mean when he said that he did not frame hypotheses? Reports from his closest friends clarify the point. William Whiston, who succeeded Newton in his Lucasian chair at Cambridge, wrote,
"It will not also be unfit with regard to myself, nor unuseful with regard to the public, if I take notice here that during the time of my acquaintance with Sir Isaac Newton, he did always own the impossibility of solving gravity mechanically. And he seemed to me always firmly persuaded that this gravity was derived from the immaterial presence and power of the deity, as it pervaded all the solid parts of the body and operated on them all."
The immaterial presence and power of the deity? That sounds like a hypothesis to me, if not also a metaphysical speculation. If Newton was not really as opposed to hypotheses as he claimed, then what was he promoting with his force of gravity? Another associate of his, Roger Coates, was more explicit in the introduction to Newton's Principia.
He who is presumptuous enough to think that he can find the true principles of physics and the laws of natural things by the force alone of his own mind and the internal light of his reason, must either suppose that the world exists by necessity, and by the same necessity follows the laws proposed, or, if the order of nature was established by the will of God, that himself, a miserable reptile, can tell what was fittest to be done.
That is the exact opposite of Kepler's program. The universe is fundamentally unknowable. Man's reason may be allowed to pursue causes up to a certain point, but ultimately, we must reach the indefinable, the axioms of physics.
Just as in Euclidean geometry, solids are said to be composed of planes, planes are composed of lines, and lines are composed of points. But what are points made of? They just are. Since they have no reason for their existence, man's reason is incapable of knowing them. They simply are. Similarly, it is useless to look for causes in the physical universe. Everything is mechanism, and that mechanism is ultimately reducible to the actions of forces of tiny particles acting in an empty box called space inside of another empty box called time. The human mind is now unnecessary to explain phenomena. The mind is composed of its biology, life is composed of physical material, and that physical material is composed of tiny particles. Therefore, someone like Kepler, who took human creativity as primary, was no more than a mistaken mystic who stumbled across his fundamental discoveries, as Laplace said, by luck. This was the approach which Laplace chose to take. But something curious occurred as he tried to apply Newton's forces to planetary motion. They worked perfectly well when applied to a system of two orbiting bodies, but as soon as a third was added, the equations became intractable, to say nothing of trying to model an entire solar system. In the course of trying to untangle the mathematical knot in which he had ensnared himself, Laplace was forced to invent what was for him a mathematical fiction, a single function from which all of the individual Newtonian forces could be derived. This function, though not known directly, needed to satisfy in every case a specific differential expression which became known as the Laplacian. The function itself later came to be called by Carl Friedrich Gauss potential. What was this potential function? Ironically, after all of the insistence of Newton and his controllers that all of the phenomena in the universe were reducible to and derivable from their component parts, it was being shown, at least implicitly, that Kepler had been correct all along. The individual actions of the entire system could only be explained if the system itself was treated as a unitary whole. The specific properties of this potential function were unfolded by the work of Carl Gauss and Lejeune Dirichlet, and then finally by Wilhelm Weber in direct collaboration with first Gauss and then Bernhard Riemann. But for Riemann, the nature of potential went far beyond that of a simple mathematical formalism, far beyond even the domain of physics itself. Like Kepler, Riemann saw in universal gravitation the manifestation of properties which were otherwise only observable in the processes associated with human creative thought.
We do not, as Newton proposes, completely reject the use of analogy, the poetry of hypothesis, but rather afterwards emphasize the conditions that must be met, and discard any notions that are not essential to the explanation, but that have arisen solely through the use of analogy. With each simple act of thought, something enduring, substantial enters into our soul. This substantial thing appears to us indeed as a unity. However, it appears, insofar as it is the expression of a spatial and temporal extension, to contain an inner manifoldness. Hence, I call this a thought object. The soul is a compact thought object, bound together in the most intimate and most manifold way. It constantly grows by the introduction of new thought objects, and upon this rests its further development. Once formed, the thought objects are imperishable, their blending indissoluble. Only the relative strength of their unions is changed by the addition of new thought objects. Thought objects require no material carrier for their continued existence, and exert no lasting effect upon the world of phenomena. Thus, they stand in no relation to any part of matter, and consequently have no position